with this portion of predicting products. Super important. All right. Completing reactions and predicting products. You should know how to predict products. All right. So let's look at the very first reaction. It says butane C4 hydrogen 10 is burned. Butane, which has the formula C4 hydrogen 10, is burned. Well, maybe we'll learn how to write a formula for butane also eventually. All right? Now, burnt means what? Burning. Burnt means what do you have to add? It's oxygen. All right? Burnt means you should remember to add oxygen. So here is my reaction. All right? Butane will combine with oxygen to give what? What are the products of a combustion reaction? Water and carbon dioxide. Water plus carbon dioxide. All right? So this particular reaction, how are we going to write it out? C4 hydrogen 10. How will I write oxygen? O2. Why do we write it as O2? Because it is a diatomic element, giving CO2 plus H2O. Now, of course, the equation is not balanced, and you will have to balance the equation. All right? That will be a 10. 16 plus 10 is 26. That will be a, what the heck did it become green? All right? Do you understand? Are we good? Now, let's do, I think you can do the second one yourself at home. Let's come to a synthesis reaction. What are we doing?
Synthesis.
We are doing a synthesis reaction. Guys, even though there exist a couple of different types of synthesis reaction, we are only going to stick to one type of synthesis reaction in our class. What type of synthesis reaction are we going to stick to? We're going to say metal plus non-metal will make what? An ionic compound. Whenever you combine a metal with a non-metal, it will make an ionic compound. This is the only type of synthesis reaction that we are going to learn in this class. And you will be asked to predict products for such a reaction. Is that understood? I may choose to give you any metal, any non-metal, and expect you to predict the product. Now, let's look at the first example that is given. A pea-sized piece of sodium is added to a container of chlorine. So, sodium is my metal. Is that right? So, in synthesis, I like my kids to know the periodic table really well. Not only do you have to remember your periodic table, but you have to remember your charges on the periodic table that will help you predict the products. Okay? So we know the staircase, and we know these are my non-metals and these are my metals. So when I have sodium, sodium is my metal. Chlorine is my non-metal. What do you expect sodium and chlorine to combine and make? Sodium chloride. Expect it to make sodium chloride. Now, suppose we have to write a reaction for this. What is the symbol for sodium? Na. Plus, how will I write chlorine? Well, it's not Cl, it is Cl2. Why is it Cl2? It's a diatomic. Which are the 7 elements that are diatomic? You have to remember your diatomic elements. Nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. These are your 7 diatomic elements. When they are by themselves, you need a subscript of 2 underneath them. Is that right? Now, I'm going to write the formula of sodium chloride. Na is a +1, sodium and chlorine is a -1. So my formula for sodium chloride will be NaCl. It cannot be NaCl2. Is that right? But then the chlorine is a 2. How am I going to take care of that? By balancing the equation. Are we good? Are we good? Are we good about a synthesis reaction?
Sure.
So, do you want to try the next one? The lithium metal is burned. So what is your metal? The metal is lithium. It is burned. Burning happens in what? Burning happens in the presence of oxygen. So that is going to be what? Oxygen. What does lithium and oxygen give? What will lithium and oxygen combine and give? What will be called the product? Lithium oxide. We will call the product lithium oxide. How will I write lithium? Li. How will I write oxygen? What is my formula for lithium oxide? What is the charge on lithium? Lithium is a +1, oxygen is a -2, so I end up multiplying with side by 2, the lithium side. So my formula for lithium oxide is Li2O. Yes, the equation is not balanced. I don't want you writing the formula of lithium oxide as LiO2. That is incorrect. It's Li2O. And so then you take care of the equation by balancing it. Are we good? So lithium is a 2. Oxygen needs to be a 2. Lithium will become a 4 and that is a 1. That is my balanced equation. Not only when it combines with a hydrocarbon. This can be classified as a synthesis reaction too. Remember, we are discussing synthesis reactions right now. All right, let's go to a decomposition reaction. All right, we're next moving on to a decomposition reaction. Now, again, there are a couple of different types of decomposition reaction, but we are going to stick to the simplest of them, which is going to be that an ionic compound will break down into what? Will break down into a metal and a non-metal. Will break down into a metal plus a non-metal. Are we good? So if they give you, what was the first reaction under decomposition that they've given you? they have said molten aluminum chloride is electrolyzed. Underline the word molten. Molten means liquefied. Molten means liquefied, not dissolved in water, but it is melted. Does that make sense? The solid is melted to become a liquid. Now, the given substance is aluminum chloride. What do you think it will break apart into? What should it break down into? Aluminum and chlorine plus chlorine. Now, what is the formula for aluminum chloride? AlCl3. AlCl3. Yes? Why? Because aluminum is a +3, chlorine is a -1. So you end up multiplying this side by a 3. How will you write aluminum? Al. How will you write chlorine? Cl2. Is that right? Because chlorine is a diatomic element. And now you have to balance the equation. So chlorine was a 3, and I needed 2 here, making that a 2. Is that right? Do we understand how to predict products of a decomposition reaction and how to write the equation? Does it make sense? Let's do the next one. Okay, this is a difficult one, but we can do it. Even though I said we are mostly going to test you on ionic becoming a metal and a non-metal. Is that right? Let me teach you one more. This is calcium carbonate is heated. All right? Calcium carbonate. What is the difference between heated and burned? You don't add oxygen when they say it is heated. When they say it's burned, you will add oxygen to the reactant side. When they say it's heated, you will not add oxygen. No extra oxygen. Now remember, anytime it's a carbonate, what could be one of the products that can get released from carbonates? CO2, very good. So what will always get released is carbon dioxide plus the remaining will be the metal oxide. Doesn't matter what carbonate they take, any metal carbonate. One of the products will be carbon dioxide, the other one will be the metal oxide. So in this case, what is the formula for calcium carbonate? CaCO3. Yes or no? What are you removing from it as you heat it? They generally put a triangle on top. What does a triangle mean? You have heated it. Triangle means what? You're heating it. Increase the heat. What is one of the products? From a carbonate, what should you be able to get? Carbon dioxide. Plus, what is the other product? And the equation is already balanced. You don't have to do anything about it. Are we good? Say that? Okay. So the next type of reaction is a single replacement reaction. Right? The next type of reaction is a single replacement or displacement reaction. Again, it's very important to keep our metals and our non-metals straight. Right? So these are the non-metals and these are the metals. Okay. So what is the reaction that is given? An aluminum strip is immersed in an aqueous solution of silver nitrate. So the element is the metal aluminum. Plus, it's put into silver and your non-metal or your anion is your nitrate. A single replacement reaction is almost like going on your best friend stealing your date. Alright? One way of looking at it. I see a lot of heads down. Why are heads down? Sit up, bud. Is it because I'm recording myself that you feel like you don't have to learn it?
No.
You'll be spending twice as much time at home trying to learn the whole thing again.
I will spend much time, yeah.
Okay. So, what do you expect the products to be? Just take, aluminum nitrate plus silver. Very good. So the product should be aluminum nitrate plus silver. Now, please understand this. Can you ever put aluminum and silver together and separate out the nitrate? Can you ever do that? Can you put two metals together or two non-metals together? You can never do that.
That's 200 divided by 40.
Do you understand? You can never ever put two metals together on the product side or two non-metals together. Does that make sense? So how will I write this reaction? Aluminum plus, what is the formula for silver nitrate? What is the charge on silver? Silver is a +1 and nitrate is a -1. So it's going to be AgNO3, giving you what? What is the formula for aluminum nitrate? What is the formula for aluminum nitrate? Nitrate. Al
parentheses NO3.
And what do you have outside? 3 plus Ag. So how will you balance the equation? What should you keep together when you balance equations with polyatomic ions? This is all review for the test. Yes or no?
This test tomorrow?
Wednesday's test.
So this will do combustion to the replacement?
No, I just wrote the formula for aluminum nitrate.
That's all good. Because scared me for a second.
So how will I balance an equation with a polyatomic ion? What should I keep together? The NO3 is 3 times. So what will I try and balance first? The nitrate, that will be a 3. And that balances my equation. Is that right? Those are, guys, I'm not done teaching all parts of a single replacement reaction yet. I'm just teaching you a portion of it. Do you see under single replacement, does it say determine if the metal non-metal is active enough to replace the metal non-metal in the compound? Does it say that? Yes or no? So after you finish your test, you will probably be doing your homework will be to memorize your polyatomic ions. And when you come back the next class, I'll probably give you a warm-up with what I've taught today. And then we will continue with the class and say, how will you decide which metal is active, which metal is not active, and whether a reaction will take place or not. Is that understood? Now, I'm going to go to number 10. I'm not going to do 9. I'm going to go to number 10. Magnesium ribbon is placed into a solution of sulfuric acid. So what is the metal here? Magnesium is placed into what? Sulfuric acid. Well, we haven't done acid formula writing yet, which I'll probably teach later. All right? So I'm just going to give you sulfuric acid. Sulfuric acid is H2SO4. Sulfuric acid is H2SO4. What do you think will be the product of the reaction? What do you think will be the product of these reactions? Remember, you cannot put two metals. In this case, the blue is my metal. The red is my non-metal. Magnesium sulfate. And what will step outside? Hydrogen. Magnesium sulfate plus what steps out? Plus hydrogen. And how do you write this reaction? Mg plus H2SO4. What is my formula for magnesium sulfate? Abdul, what is my formula for magnesium sulfate?
Mg I can't see the board, so.
Yes, Nadia?
No.
That is correct. MgSO4.
Take it out my priority field. You give me 5 minutes to
And how will I write hydrogen? H2. Is my equation already balanced?
Yes.
Wasn't this the same reaction when we dissolved Phenny?
Yes.
Instead of using sulfuric acid, what
Yes.
acid did we use?
Hydrofluoric acid.
So what should be my product?
Hydrogen.
It's like zinc chloride.
What is the formula for zinc chloride? What is the formula for zinc chloride?
Wait, ZnCl2.
ZnCl2
ZnCl2.
plus. Now, the hydrogen, the acid did not react with copper. Do you remember that? Did any reaction happen with copper? No. Why? Because copper is not as reactive as hydrogen is, which is what we'll come to next class. Does that make sense? Which reaction? So if I take copper plus HCl, do you think this reaction will occur or not? Will this reaction occur? If I take copper instead of zinc, there will be no reaction. So how can we predict? Oh, when there is no reaction, you should be able to say there is no reaction. And we'll learn that next class after your test. Does that make sense? All right? So we're going to do the last and final type, which is a double replacement reaction. Alright? The last and final type is a double replacement reaction. Now, let's do the first one. Sodium phosphate. Sodium phosphate. Sodium is my metal. Phosphate is my anion. Plus manganese 2 chloride. Manganese 2 chloride. Now remember, you can never put two metals together or two non-metals together. What will be the products of my reaction? Sodium chloride, and you can't put phosphate manganese. What will you put? Metal first. Manganese 2 phosphate. So the products will be sodium chloride plus manganese 2 phosphate. Now I need everybody writing out the formulas and balancing the equation. I'm going to stop at this time.